I already discussed reflexive and symmetric relation. Today I will discuss transitive relation. Definition 5. A relation R on a set A is called transitive if whenever AB belongs to R and BC belongs to R, then AC must belongs to R for all ABC belongs to set A. So whenever AB present, BC present, AC must be present. That's about transitive relation. So for all A, for all B, for all C, if AB belongs to R and BC belongs to R, then AC belongs to R. If set A contain A, B, C, then empty set is the smallest transitive relation A, B, B, C, C. The diagonal set that is also transitive. This relation is reflexive, symmetric, also transitive. Next R3 AB, AC. This is transitive. Next R4 AB, BC, AC is present. It is transitive, and the largest transitive relation is A Cartesian product A. There are no fixed formula available for number of transitive relation. I already discussed number of reflexive relation, number of symmetric relation, but for transitive relation as it is not available, so I am not writing anything. Next, less than equals to, greater than equals to, less than, greater than, equals to, divide, subset are transitive relation. Suppose 1 is less than equals to 3, 3 is less than equals to 5, then 1 is less than equals to 5. Let's see some example of transitive relation. Example 11. Which of the relation in example 5 are transitive? I discussed same example for reflexive, also for symmetric. Just go through previous lecture. Now we have some relation R1. Here 4 1 is present, 1 2 is present. There should be 4 2. But 4 2 is not present, so it is not transitive. Even 3 4 is present, 4 1 is present, so 3 1 must be present. 3 1 is not present, right? So as 4 1 1 2 4 2 absent, then 3 4 4 1 3 1 absent. So it is not transitive. Next R2 1 1 1 2 2 1. In this relation 2 1 present, 1 2 present. So there should be 2 2 present. As 2 2 is absent, hence it is not transitive. Next relation R3. Here 4 1 is present, 1 2 is present. So there should be 4 2. 4 2 is absent, right? Hence it is not transitive. Next R4. It contains 2 1, 3 1, 3 2, 4 1, 4 2, 4 3. Here 4 3 is present, 3 2 is present. 4 3 3 2, so 4 2 must be present, it's present. Then 4 3 present, 3 1 present, so 4 1 should be present, it's present. Hence we can say it is transitive. We have pairs like 3 2 2 1, 3 1 is present, 4 2 2 1, 4 1 is present, 4 3 3 1, 4 1 is present, 4 3 3 2 4 2 is present. Hence it is transitive. Next R5. It contains 1 1 1 2 1 3 1 4 2 2 2 3 2 4 3 3 3 4 4 4. Now 1 2 2 3. So 1 3 should be present. Yes, it present. 1 3 3 4. So 1 4 should be present. It's present. 1 2 2 4. 1 4 is present. Yeah, all transitive relation are present, hence it is transitive. Next R6, just 3 4. It is not in the form of AB, BC. Whenever AB, BC is present, then AC must be present. Here just 3 4 one order pair, hence it is transitive. So we found R4, R5 and R6 are transitive. Now next example, example 12. Which of the relation are transitive? I already discussed same example for reflexive and symmetric. Just go through that. Here R1, R2, R3, R4 are transitive. R1 is transitive as A less than equals to B, B less than equals to C, then A can be less than equals to C. Hence R1 is transitive. R2, A greater than B, so you can say 5 greater than 3, 3 greater than 1 means 5 greater than 1. So R2 is also transitive. Next R3, A equals to B or A equals to minus B. So A equals to plus minus B, B equals to plus minus C, then A can be equals to plus minus C. Hence R3 is transitive. Now R4, A equals to B, B equals to C, then A can be equals to C. It is transitive. Next R5, A equals to B plus 1. So 5 equals to 4 plus 1. 5, 4 is one order pair. Then 4 equals to 3 plus 1. So 4, 3 is another order pair. Now is 5, 3 can be order pair like 5 is 3 plus 1? No. Hence R5 is not transitive. Next R6, A plus B less than equals to 3. 2 plus 1 less than equals to 3. So 2, 1 is one order pair. Then 1 plus 2 less than equals to 3. So 1, 2 is another order pair. Now is 2, 2 another order pair. 2 plus 2 less than equals to 3? No. Hence R6 is also not transitive. We found R5, R6 are not transitive. Next example 13. Is the divide relation and the set of positive integers transitive? Yes, it is transitive. Suppose 16 divide 8, it's 2. Now 8 divide 4, it's 2. So 16 divide 8, it's one pair. Then 8 divide 4, it's another pair. Then we can say 16 divide 4. Yes, hence it is transitive. We can write B equals to AK, C equals to BL, then we can write C equals to, in place of B we can write AK, so AKL. A divides C. So we can say it is transitive. Divide relation is transitive. In today's lecture I discussed transitive relation with some example. In next lecture I will discuss combining relation. If this lecture is helpful for you, please like, share and subscribe. Thank you.